Welcome to Chapter 21 on editing, evaluating, and troubleshooting assemblies. On this chapter, in this video, we're really going to focus on one item: tools, evaluate, performance evaluation. This set of tools may not have got the attention it deserves in the regular chapter, so I'm going to spend a little bit more time on it here in the introductory video. Be aware that there are also things that you can do here, such as measure, get the mass properties, section properties, do geometry checks. Assembly visualization I know is covered in the chapter, and some other things such as interference detection, clearance verification between parts, and hole alignment. I'm just going to go through some of the various tools that are available in the performance evaluation. SolidWorks performance evaluation for assemblies used to go by another name, but I think the performance evaluation name really kind of sums up the kind of information that you can get from this dialog box. We're going to open this up as big as it can get here, and so we can see as much as possible. The first section in performance evaluation is the open performance. This means how long does it take to open each file, and how much does each file contribute to the overall open time for the assembly. So you can see here that the most time goes to the frame, which makes sense since the frame is the most complicated part in the assembly. It's got surfacing in it, and it's turned into a solid. It's taking up time from a visualization point of view, and also just due to the geometry and features. The second part may not be quite as obvious. The top pivot bracket is actually this small red part on the rear derailleur. This is also a surfaced part. It's got some swoopy features in it, but it's not what you'd expect, and this is a good candidate. In fact, the whole derailleur assembly probably a good candidate for simplification or making it lightweight. The bike crank, again, has some surfacing, complex shapes, and this parallelogram front is, again, part of the rear derailleur. So we're able to pick out some parts from the assembly using this chart that are maybe not obvious in terms of eating up a lot of resources from your computer. The left crank, bike crank chain ring, the lower pivot bracket, and that's again on the rear derailleur. So the rear derailleur is really causing us a lot of grief compared to some of the other components in this assembly. That's just good information to have when you're moving forward and trying to use your resources wisely. The next item here, previous version references. This is going to tell us that one of the 47 parts in this assembly has not been updated to the new version of SolidWorks. In fact, it's still an old version, and we can see which file that is. That front hub of the bike wheel, the front wheel in particular, right here, this black. So if you want your assembly to open faster, it might behoove you to update that part and resave it. Now, display performance is different from the open performance because, as you know, SolidWorks has to turn every curved surface especially into triangles, and the more the curvature, the smaller the triangles are, and the more of them there have to be, the longer it takes. If we look at some of these parts, we can tell exactly where our resources are going. So we've got a pulley, which is again in the rear derailleur, and this is going to have a lot of triangles. In fact, the most triangles, and there are two of these parts. The part is very small and detailed. The bike crank is going to have a lot of triangles because of the curvature and complex surfacing in that part. And if we go down the list, you can see how long it's taking some of these parts to display. If you're having problems with your assembly, taking a long time to repaint or regenerate, then one of the things that you can do is hide these parts or suppress them. Hiding parts is going to solve any problems that you have with the graphics triangles, and suppressing them will fix your graphics problems as well as the performance problems, which is more of a rebuild issue. Shaded image quality. Obviously, if you have the image quality of a shaded part set very high, and that's in your tools options settings, it's going to take longer to display that part. longer for your computer to calculate the display for that part. The rebuild performance for an assembly, rebuilds are really going to affect mates. Or I should say mates are going to affect the rebuilds. So 28 mates are evaluated when this assembly is rebuilt. The other mates are going to be in part of a subassembly, and therefore they aren't evaluated. And you can get a report about the rebuild for the assembly by clicking here. A rather short report. So here it's going to give us an actual time figure for how long it took to regenerate the graphic for the assembly. One of the things that you'll notice is that we've got a rebuild symbol on the frame, and so that has not been rebuilt. Close this down, come into the assembly, hit Control Q on the keyboard. Control Q is a forced rebuild, so it will rebuild anything in the assembly regardless whether it needs it or not. The rebuild symbol is SolidWorks' way of saying that it needs to be rebuilt. Now we can see that it's not, that even a forced rebuild is not rebuilding the assembly or all of the parts in the assembly properly. The culprit here, don't know if it's the only culprit, but yes it is. The only culprit is an in-context plane. We've talked about this before, talking about in-context relations, where in-context features can take extra time to rebuild. The next item we'll have a look at is the settings performance, and this is going to help us evaluate how this assembly is performing against our setting for large assembly mode. Now each SolidWorks user is going to be a little bit different. 500 components is the default threshold for a large assembly. Some SolidWorks users will think that that's a very, very large number. Other SolidWorks users will think that's a very, very small number. So you got to set these settings to suit how you are actually using the software. We can also take a look at the assembly statistics for this assembly. Total of 141 parts, 45 of those are unique. We've got a couple of sub-assemblies in here. We've got several individual bodies and a few configurations. The maximum depth of this assembly is 3 sub-assemblies. And you'll notice that we've got 28 top-level mates and probably quite a few sub-assembly level mates as well. So this information is all very useful. From here you can also get to the assembly visualization window, which will color the parts according to certain criteria. For example, the size, the quantity, the total number of graphics triangles, open time, rebuild time. This is all very important information. While it may not help you model directly, it's going to help you understand where your performance and resources are being used most in this assembly.